Hello everyone, my name is Berk Erhan Yüksel. I'm going to answer the questions about experiment 2, namely voltage and current waveforms, hysteresis loop, and parameter determination of a single-phase power transformer. In the first question, at the laboratory, the RMS values of the current that was passing through the shunt resistance were found different at oscilloscope and wattmeter displays. Normally, the RMS values are calculated from this equation, especially in distorted waves in this lab, like in saturation region or whatever. As you can see in the oscilloscope, we have distorted voltage waveforms in the yellow label. Therefore, the wattmeter use this method that is more accurate version of the RMS value. On the other hand, the oscilloscope use this equation, take the I peak to peak and divide it by square root of 2. Therefore, the RMS values that was measured from oscilloscope more than the wattmeter ones is like in the laboratory. In the second question, we obtained core loss, and the question is why we used core loss by looking at only pH curve. The core loss consists of two elements that are eddy currents and hysteresis losses. We can ignore the eddy currents in this question because we operate at 50 Hertz. You can see the eddy currents representations. As 50 Hertz is a low frequency, we can ignore the eddy currents. And also we limited the eddy currents using the electrical sheets or electrical steels in the laboratory. Therefore, the only core loss is hysteresis loss, and hysteresis loss can be measured by this region. Therefore, we can measure the core loss by only looking this, only pH curve limitations and pH curve regions in this question, as you like. Okay, if we look at the third question, in this open circuit test at the laboratory, we use different RMS voltages, such as 50 volt RMS, 100 volt RMS, or 220 volt RMS values. In these tests, overall approximate circuits was like this, as you can see. Because of high impedance values of RC and JXM, the formed currents I1 were not high at rated voltages. As you can see, the impedances are very high, and the equation we rated voltages is equal to current and impedance values. As the impedance value is very high, the current will be low. Low current values will not get or cause a damage to the circuit. So we used rated voltage values. On the other hand, we use rated current value instead of voltage values in the short circuit tests. Since the impedance of the approximated circuit model R equivalent and Jx equivalent were very low, the formed currents at rated voltages may be very high. According to this equation, the low impedance values will cause a large current values. Therefore, these large current values will be cause a damage to the circuit because of these impedances values. Therefore, we used approximated rated current in order to test the circuit without any damage. At the final, we use rated voltage values in open circuit test and rated current values in short circuit test because of gave no damage to the circuit. This is the final question.